the afternoon of May 15, 1954, Mrs. William E. Boeing, wife of the founder of the Boeing Airplane Company, christened a new airplane. Then, America's first jet transport, the Boeing 707, was towed into the sunshine. The new airplane, a prototype jet transport, has been built and wholly financed by Boeing for use as a demonstrator to show the airlines what such an airplane can do on commercial air routes. The primary design objectives of simplicity and reliability have been strictly maintained. It is a brand new airplane, but it bears a definite relationship to Boeing's preceding jet airplanes, the B-52 and B-47 bombers, having similar swept wings and pod-mounted engines. Compared with the Boeing Stratocruiser, the new airplane is somewhat longer, but of a lesser wingspan, making it readily adaptable to present field space and hangar facilities. The forward cargo door opens on the 90-foot-long cabin. In this prototype airplane, the cabin is unfurnished, except at the forward end, where flight test instrumentation is installed. Forward of the instrumentation area is the flight engineer station. The panel includes engine, instruments, fuel, electrical, and pressurization system instruments and controls. The instrument panel is hinged and can be swung so that either the pilot or co-pilot can monitor the panel when no flight engineer is included in the crew. There are substantially fewer instruments and control levers in the cockpit than in today's transports, which is typical of the overall simplicity achieved in this new airplane. The control runs from the pilot's control columns and rudder pedals to the empennage control surfaces are simple. No sharp bends, no complications. Control cables operate basic flight controls through spring tabs. There is no mechanical or power boost. Pilot effort moves the control tabs, which in turn cause the control surfaces to move throughout their range of travel. All control surfaces are aerodynamically balanced. This system of control has been fully proven on the Boeing B-52 jet bomber. Also proven on the B-52 is the system used for longitudinal trim, the adjustable horizontal stabilizer. The stabilizer is moved to change its angle to trim the airplane through a motor control or manual system. The lateral control system handles the airplane easily and positively at all speeds. The ailerons have the same type of tab as the rudder and elevators. Supplementing the aileron controls are the hydraulically actuated spoilers on the upper surfaces of the wing. Spoiler operation is modulated through connection to the inboard aileron control system. Up spoiler with the up aileron reduces lift, increasing the rate of roll. The spoilers not only augment lateral control, but also double as air brakes. With all spoilers extended symmetrically as air brakes, the airplane rate of descent is greatly increased. They may be operated as a part of the lateral control system at the same time they are in use as air brakes. The drag brake function of the spoilers is useful to quickly and easily control the rate and angle of descent on final approach for landing. The highly efficient double-slotted wing flaps are set at a moderate angle for takeoff, enabling the airplane to become airborne with a minimum runway used. When fully extended, they provide maximum lift for low-speed approach and landing. They can be positioned to any degree as pre-selected by the pilot and are hydraulically operated in symmetrical pairs. The position of each portion of the four flaps is shown on indicators in the pilot's cockpit. There is exceptional accessibility to the flap track, hydraulic lines, and control cable runs. The Boeing jet transport is supported by a conventional tricycle landing gear incorporating four-wheeled main trucks plus a dual-wheeled nose gear. The four wheels of each main gear permit use of standard size wheels and provide increased tire surface on the runway, resulting in improved braking. The landing gear retraction sequence The control lever in the cockpit is operated by the pilot. The doors open, the gear retracts, the doors close. The nose gear operates simultaneously with the main gears and in the same manner. Stopping the gear down sequence momentarily shows inside a main gear wheel well the maintenance accessibility of hydraulic components, lines, and valves. Inside the nose gear well, the same accessibility prevails. The nose gear is hydraulically steerable. The landing gears can be lowered at high air speeds to serve as air brakes in combination with the spoilers, making possible higher rates of descent. The background of the new Boeing jet transport includes over 21,000 hours of wind tunnel research on swept-wing multi-jet aircraft and over 5,000 hours of test flying on the B-47 Stratojet and the B-52 Stratofortress. This new jet transport is 130 feet in wingspan, approximately 11 feet less than the Stratocruiser, and 128 feet long. The tail, 38 feet above the ground, may be folded to reduce the ground height to approximately 18 feet. The four engines on the new Boeing are Pratt & Whitney turbojets, similar to the military J-57 engine used on the B-52. The jet engines are suspended below and forward of the wing on struts, similar to the installations on the B-47 and B-52 airplanes.